Okay, so this is how we're going to try and do labs with Digital Learning Days. What I've pulled up here is the same application you can pull up with the phet.colorado.edu simulation. This one's called Waves Intro, and I'm on the sound setting at the bottom, which is just off screen down here. Once you turn on both by clicking both, if you just leave it as waves, it's only going to see the waves. Make sure you click both, get both particles and waves in there. Now we're going to ask you about these red dots here, a couple of things. First thing is where the red dots appear in this kind of wave, and you need to know what kind of wave it is in order to do that. The two types of waves that we can categorize by particle motion is either transverse or longitudinal. This particular wave does not move with an S shape. It moves in pulses like that of air particles being bunched together. So these are in compressions. These red dots end up pushed with the rest of the white dots in compressions. In between these black areas here that move out that the red dot's going to skip over, those are called rarefactions. And so that'll answer two of those questions on the Google form. Compression is where the red dots are. Rarefaction is where the red dots skip over because all the air particles are compressed in the compression for the wave, and the rarefaction is where it's spread out so they don't bunch up there. The other part is that this is a longitudinal wave, not a transverse wave. Then the last part is whether this sound wave is a mechanical wave or an electromagnetic radiation. Sound waves are mechanical waves. You can check these out in the notes as well. Make sure you jot some stuff down so that this way you can keep it straight for the Google form. Now the next thing that we're going to play with here is you see both particles and waves, which we'll want to see, and then you can play the tone. This should record what tone you have and based on what frequency you have. So low frequency tones are low notes. High frequency tones are high notes. What we can see here is the higher the frequency goes, the faster this speaker vibrates and the closer together the compressions are and the rarefactions are. The lower the frequency is, the slower this vibrates and the longer, more stretched out the waves become. All of these interactions as sound appears to us or is apparent to us when we're listening to sounds, they sound low if the wavelength is long and the frequency is low. And they sound high pitch if the frequency is high and the wavelength is short. All right, the last thing we're going to play with here is the amplitude of the wave. Now, the amplitude, as far as what we can see here in a compression or longitudinal wave this type here, is how loud it is. But really, it's about how much energy comes out of the speaker, how energetic the speaker is vibrating. It's the same frequency tone, and if you did a higher frequency, it would vibrate faster, but just not with as much energy. There's those high frequencies. It's a very high pitch, but it's just not very loud. There's a low pitch, not very loud. The amplitude maximum is going to create loud tones for us. Okay, so amplitude, higher amplitude is louder, lower amplitude is softer. Frequency, higher frequency is a high pitch, a high note, and lower frequency is a low pitch, a low note. So just under 5 minutes, pretty much everything you need to know about the lab. Have fun playing around with this and listen to some music today and listen to the different tones that you're hearing and realize those are really just air particles moving back and forth. Every music note you have ever heard is based on waves. So hope you're having a good Friday. Enjoy your lab.